Hello, today we are going to study the section 8.3, which is the method of undetermined coefficient in that later. Okay, so firstly, let's take a look at what we are going to do in this section. We are going to solve non-homogeneous differential equation. Okay, so in 8.1 we solved. So in 8.1 we know how to find general solution to homogeneous, right? And 8.2, which is called the general result for differential equation of order n. So do you still remember what's the solution for the non-homogeneous? The solution includes two parts. So y plus yp. So it's like this is the general solution to homogeneous differential equation, which is p dy equals 0, and this is called a particular solution because we add a small p there, particular solution. This is the theorem in section 8.2. Okay, so today we're going to use 8.2, or we are going to use this solution to find the solution to the non-homogeneous. Okay, let's take a look at example 1. Let's see. We are going to introduce the method from the example. What's the idea for this kind of non-homogeneous differential equation? We do this way. So let's see. We have p dy equals f, right? So we want to times another thing on both sides. So we want to times another operator. For example, we want to times AD on both sides of the equation. So AD times F. And we want to change this into 0. So in this case, we can solve this solution, right? This becomes homogeneous. So we just want to change a non-homogeneous into homogeneous and then solve it. Okay, that's the idea. Let's see example. Determine the general solution to this non-homogeneous differential equation. D plus 1, D minus 1, y, which is 16e to the 3x. Okay, let's see. Definitely this is not homogeneous differential equation because the right side is 16. We have 16e to the 3x. So firstly, let's take a look at what's the general solution to the homogeneous, associated homogeneous solution. So PR, if we just look at the homogeneous, that means the right side equals 0. So PR equals what? Means R plus 1, R minus 1. Right? If we make this equal 0, so we can get R equals -1, R equals +1. So what's the general solution corresponding to the homogeneous? So y should be C1e to the -x plus C2e to the x. Is that right? So this is the general solution. So this is general solution to p dy equals 0. Okay, so we already got the first part, general solution to homogeneous. Next, we are going to find the particular solution. So let's see how to find the particular solution. We need what? We want to change the right side into homogeneous. So we want to times AD to the F, make that into 0. That means ADE to the 3x, we want to make this into 0. Okay. So think about what is that, like what is going to be operator can make e to the 3x equals 0. Think about this thing. Think about d minus 3. Don't worry too much. In the future, whenever we see e to the ax, we always use this. d minus a. Okay, d minus 3 e to the 3x. Let's see. This means what? That means derivative of the 3x minus 3 times e to the 3x. So derivative of this one definitely chain rule, which is 3e to the 3x, right? So actually, d minus 3 can make this into 0. In the future, so in general, what can make e to the ax into 0? D minus a. Okay? So let's see. Right now, we're going to times e minus d minus 3 on both sides. So d minus 3, both sides to the differential equation, original differential equation. And this here 16e to the 3x. And here we still have d minus 1 and d plus 1 and y, right? And actually we change this non-homogeneous into homogeneous after we times d minus 3. So let's see. I'm going to rewrite this a little bit. D minus 3, d minus 1, d plus 1, y equals 0. Okay, and what's the solution to this one? The solution to this one should be y equals what? Should be, okay, so I'm going to write this at the end. So I'm going to write down the general solution corresponding to those two in front. C1 e to the negative x. C2 e to the x. The order of those two doesn't matter. Okay. And here, for this one, I'm not going to use C3. I'm going to use A. You can use C3, doesn't matter, but I just want to separate from those two. I'm going to use A naught times e to the corresponding to that one should be 3x. Isn't that right? 3x. Okay. This is the solution to this one. So, in this solution, this actually we got this at the beginning. This is a general solution to homogeneous. And we know the total solution going to be the sum of homogeneous plus particular solution. So we know what is particular solution. So this one should be the particular solution. So we found the form of the particular solution. Let's write down yp. Yp equals a naught e to the 3x. So first step, find general solution to the homogeneous, and then we make the non-homogeneous into homogeneous, find the solution, and decide which one is the particular solution. And next we are going to find a naught, okay, the coefficient, because this is the particular solution of the differential equation. So this one should satisfy the differential equation, right? We want to determine the a naught. Let's plug in. So let's plug in the differential equation. The original differential equation is like d minus 1, d plus 1 y, which equals 16 e to the 3x. So we want to plug this into this differential equation. That means d minus 1, d plus 1, a naught e to the 3x equals 16 e to the 3x. Okay, let's simplify the left side a little bit. This one means d squared minus 1. D squared means what? D squared means the second derivative of this function, right? Second derivative of that function should be 9 times a naught e to the 3x. Is that right? And then minus just itself. If you forgot this one, please review 8.1. How to find p dy. Okay, how to find the p dy? So second derivative minus just the original function, and this equals 16 e to the 3x. So from here we can simplify and solve for a naught. The left side becomes 8 a naught e to the 3x equals 16 e to the 3x. Because e to the 3x cannot be 0, exponential function, the range is always greater than 0. So we can just cancel them. Divide by e to the 3x. That means 8 a naught equals 16. A naught equals 2, right? So we find a naught. This is called undetermined coefficient. Okay, undetermined coefficient. And now let's write down our general solution. C1 e to the negative x, C2 e to the positive x, particular solution, which is a naught, 2 e to the 3x. So this is general solution to the original non-homogeneous differential equation. Okay, so that's the procedure. Don't worry too much. So let's do one exercise. Okay, we are going to do one more exercise. Let's see this problem. Okay, firstly, let's find general solution to the homogeneous. So to the homogeneous, we need to have a quick review what we did in 8.2. So d squared plus 1, that means PR equals r squared plus 1. And we know this r equals plus minus ri, right? And corresponding to that one, the solution should be e to the ax sine bx and e to the ax cosine bx. And to this one, a is 0 and b is 1. So our solution should be, general solution should be sine x and cosine x. To p dy equals 0. Homogeneous. Next, we times AD on both sides. So which AD can make the right side equal 0? Definitely should be we times d minus 1 on both sides, because this is e to the 1 times x, right? E to the x. Okay, d squared plus 1 y equals 6 e to the x. Like d minus 1 here, and which make the right side become 0. And what's the general solution to this one? Homogeneous. Okay, we know how to find the general solution, right? General solution should be C1. We still write down C1 cosine, sine, cosine in front, and a naught e to the x. So corresponding to that one, that is a naught e to the x. So this is yp. Particular solution. Yp equals a naught e to the x. Plug this into original differential equation. D squared plus 1y, which equals 6 e to the x. Okay, so that means d squared plus 1 a naught e to the x equals 6 e to the x. And d squared means second derivative. Second derivative of that one still become like a same thing, right? Because e to the x derivative is e to the x. Second derivative is still the same thing. And plus itself. So you can see here's 2a naught equals 6, a naught equals 3. So what is our general solution? C1 sine, C2 cosine, plus 3e to the x. So this is the general solution. Okay. So here we did one example, one exercise. Now I'm going to give you the definition. Okay, definition. It's called method of undetermined coefficient. Undetermined just means find the a naught. coefficient. Okay, so let's see. Firstly, we have P dy equals f. Okay, and we find solution to P dy equals 0. And next step, we times AD on both sides. This is called annihilator equals ADF, and then we make the right side into 0. And here AD is called annihilator. Okay, AD. So let's see. And then we solve. Third step, we solve for A naught. Okay, so this is the procedure, or it's called definition of method of undetermined coefficient. And you have already known like how to do this kind of problem, right? But we only did special problem like for the e to the ax on the right side. How to make this into 0? We times like a d minus a can make this into 0. But for the right side, sometimes it may be some other form, maybe like e to the sin x, cosine like 2x, or e to the 5x sine 2x. That's kind of thing. Or x squared e to the 3x. So if the right side equals those kind of function, how to find annihilator? Okay, so that's the next thing we are going to do. Let's take a look at the second example. Show that AD equals d squared plus 4 annihilate this kind of function, 5 cosine 2x. Okay. Let's take a look. Let's annihilate this function. That means AD times f equals 0. That means this times 5 cosine 2x can make that into 0. Okay, we want to see if that is true. Second derivative, so like here is constant, we can just take that to the front. And the second derivative of cosine 2x should be 2 sine 2x, and then should be negative. First derivative is negative 2 sine 2x, and then again, so going to be negative, like 4 should be negative 4, and the cosine 2x. That's second derivative, right? And just plus 4, so plus 20 times cosine 2x. That means what? So negative 20 cosine 2x positive definitely equals 0. Okay, let's see. We can take a look at this one. What is the, if f equals 5 e to the 4x, what is AD? As we said before, it's just d minus a, d minus 4, right? So if f equals like e to the negative 2x, what is AD? AD should be d minus negative 2, so which is d plus 2, right? And then in general, so let's see, in generally, ADF equals 0. Who can make the f capital F equals 0? If and only if and only if y is the solution, okay, y equals fx is the solution of AD. Okay, so let's take a look at, for example, what's the meaning of this one? Okay, I can give you one example. Do you remember, like, for example, sine 2x? This is the whole solution. That means a, like a plus bi, so this should be complex, corresponding to the complex r. A equals 0, b equals 2, so should be like d squared plus 4. Is that correct? Because the solution will be r equals plus minus 2i. So you can see sine 2x actually is solution to d squared plus 4, right? Y equals 0. So how to find AD? You just see F is whose solution. So this is our AD. That's the idea. Okay, I'm going to give you like the general result here. So f of x must be one of the following form. Let's see, the first one. The f can be like a constant, x to the k e to the ax. Okay. Let's see, general, and then we have corresponds to the complex number. So x to the k e to the ax cosine bx. Oh, we have like x to the k e to the ax sine bx. Number 3, like the sum of 1, 2, 2. So the right side must be one of the following form. Then we can find our AD in that later. So let's see. If f equals this one, x to the k e to the ax, a is a real number, okay? Then what is our AD? AD should be, we know if k equals 0, if there's no that term, that means d minus a, like, can make this into 0, right? But we have x to a product k, so that means here we should have multiplicity has some power, okay? So what's the power of that? That should be k plus 1. E to the ax can make that into 0. Y equals 0, okay? We can have a quick review here if you don't worry too much. So let's see, what is d minus 2 squared, like a solution? Do you remember? Should be e to the 2x, but because that we have the power 2, so we should have x e to the 2x, right? So take another look at this example. So what's the solution to this one? Should be e to the 5x, x e to the 5x, and x squared e to the 5x, and x cubed e to the 5x. So that's why if we have k, like a k e to the ax, so here should be k plus 1. That's why. Okay. Let's see. AD equals d minus a to the k plus 1. Evaluate each of the following functions. Functions, they are e to the ax, x e to the ax, and x to the k e to the ax. Okay, so first case, if r is real, so for the e to the ax, even we have some x to some power in front, so we know what's the annihilator, right? First case. So let's see. Okay, so here remark, when a equals 0, that means what? That means the right side is just like x to the power k, because e to the 0 is 1, right? So x to k, when the right side just has to the k, in that case AD is same thing, just d minus 0 is just d to the power k plus 1, because d minus a is 0, right? Annihilate x squared and x to the power k, just like this. Let's take a look at this example. Find the general solution to this one. Actually, we did this in the first example already, but let's do this again. Okay, similar. So, what is the first step? Find the general solution corresponding to homogeneous. So, can I write down this a little bit quicker? So, general solution corresponding to the homogeneous should be C1 e to the 4x, C2 e to the negative x. Right, first step. Okay, this is the solution. We're homogeneous. We write down this as YH. Okay, homogeneous. And next we find annihilator. Annihilator equals what? Annihilator should be d minus 4. Is that correct? Because the right side is e to the 4x. So we times d minus 4 on both sides. Y. Then the right side becomes 0. So here, let's simplify a little bit. Square d plus 1y equals 0. And let's write down the general solution corresponding to this one. Y should be, general solution to this one, it should be e to the 4x, x e to the 4x, right? And e to the negative x. Okay, and this is the general solution. We have C1, and here I'm going to write down C2 because this is corresponding those two homogeneous solution. So here I write down this is our particular solution. So what's the YP? So just exclude e to the x. So look at the YH and compare those two. Who's the left? X e to the 4x times a naught. So that's the particular solution. So that's how we find the particular solution. Okay, YP equals a naught x e to the 4x. Plug into differential equation. D minus 4 d plus 1 y equals 15 e to the 4x. And because we're going to plug in this differential equation, I'm going to simplify this a little bit. That means like a polynomial, we just do polynomial thing, like a multiplication. So d squared minus 3d and minus 4, right? And times this a naught x e to the 4x, and right side is 15 e to the 4x. And let's do the second derivative of that one. Interesting. Okay, so second derivative probably is hard to find. Let's just find the first derivative. So a naught x e to the 4x first derivative should be product rule. Okay, product rule. Let's just do this without x naught. Maybe that's easier. So this becomes what? X e to the 4x first derivative product rule f prime g e to the 4x plus x g prime, so times 4 times e to the 4x, right? And if I simplify this, this is like 1 plus 4x. One plus 4x, factor e to the 4x out. And because we have d squared, definitely we have the second derivative. So second derivative, that means we take the derivative of this one, first derivative. Product rule again. f prime g plus f g prime, like this. Okay, and I'm going to simplify this a little bit. Factor e to the 4x out, and what left? 4 plus 16x and plus 4. So it's going to be e to the 4x, 8 plus 16x. Okay, so this is the second derivative. Now plug in the first derivative, second derivative into our left side. So second derivative, and we still have a naught in front. A naught e to the 4x, 8 plus 16x, and then minus 3 first derivative, okay, and then minus 4 a naught x e to the 4x, and equals 15 e to the 4x. Let's simplify. So e to the 4x, actually we can just cancel all them because they cannot be 0. So we can make our calculation a little bit easier. Let's see what we get. For the x, x term, so here we have 16, we have 12. 16 minus 12 should be 4, right? And the 4 minus another, x term equals 0. So the right side also is 0. So that means our calculation is correct. Next, let's just take a look at the constant term. Constant term should be 8 a naught. Okay, and here should be minus 3 a naught. Is that right? Constant term. And that's all. And this equals 15. That means 5 a naught is 15. A naught equals 3. So what's our particular solution? Should be 3x e to the 4x. In this case, what's the general solution? Homogeneous, I think it's 4x, right? Let's take a look at 4x and then negative x, okay? And plus c2 e to the negative x, and plus particular solution e to the x e to the 4x. Okay, this is example 3. Let's take a look at the exercise. Okay, we can try the exercise problem. Solve this. Or sometimes the problem may be just given by this way. So in the homework, it may be given by both ways. So if given by second way, we just need to factor this out, right? And here's the solution. You should try this by yourself before you look at my solution. I'm going to find a general solution to homogeneous. And next I times annihilator on both sides, and annihilator should be d minus 2. And the right side becomes 0. And this means, so my solution should be e to the 2x, e to the 3x, x e to the 2x. So my particular solution should be e naught x e to the 2x, and I'm going to plug this into the second, plug into original differential equation, so which is plug into this one, and here I already simplified. Same thing here. First derivative, e to the 2x, x2 e to the 2x, e to the 2x, 1 plus 2x. Okay, and the second derivative, which is product again, 2 e to the 2x, f g prime 2, and I factor e to the 2x out, so it becomes 2 plus 4x plus 2, which is a naught e to the 2x, 4 plus 4x, and plug them into the differential equation. So which is a naught e to the 2x, 4 plus 4x, minus 5, first derivative a naught e to the 2x, 1 plus 2x, and plus 6 a naught x e to the 2x, which is 7 e to the 2x. And based on the problem, no. So we can take a look at the x term. 4 plus 10, 4 minus 10, negative 6, and plus 6 definitely cancelled. Okay, 0. So only matter the constant term. And I cancel all the e to the 2x, both sides. So that means 4 a naught minus 5 a naught equals 7. So this is negative a naught equals 7, a naught equals negative 7. What is the particular solution then? Negative 7 x e to the 2x. General solution is going to be yh plus yp, so which is c1 e to the 2x, c2 e to the 3x plus, so here should be minus 7 to the x. For this section, we can stop here. In the next, for this section, no, for this class, we can stop here, but for next class, we are going to do we are going to find AD for other kind of function. We are going to find AD for e to the ax, cosine bx, e to the ax, sine bx, or maybe some extra k in front. Okay, that's what we are going to do in the next class.